Hey everyone. I have some exciting news. This morning I released the Preprocessor Build to main, so now everyone is on that build, which is a real relief because, as you probably know, I've been working on that for months now, probably almost a year on and off. So I'm really pleased that's done. I know a few people have been using it for a few weeks now on the insider build, and thank you for it very much for doing that. That's helped iron out quite a few issues. So it should be fairly stable now. Should be working quite well. Let's just fire up 10x. So yeah, fixed a few things with the preprocessor build. The hover over on defines is now working and now accurate. Now it goes to the right place. So it's actually using the preprocessor rather than the parser now on the hover over. I've also added, as you can see, it's color syntax highlighting the hover box now as well, which is nice. And it should be, the if defs should be working. Let's find a better one. So as you can see, stuff's grayed out if it's if-defed out, and that should all work with the changing of configs as well. Volume low for people. I did turn down the gain a bit on mine. Let's turn up a little bit. Is that any better? Okay, anyway, let me know if you can't hear me. I'll bring the microphone a little bit closer. So yeah, the switching of the config, it does work, but at the moment it does a full reparse. So when you switch, it might take, depending on the size of your project, a few seconds or a few minutes to reparse everything. And on big projects like Unreal, that could take like a couple of minutes or so on some systems. So that's not ideal yet. What I will be doing is changing it so that it uses the cache, just like when you start up 10x normally. It will read the parser data from the cache and hopefully only take a few seconds to read that in. So it should be a lot quicker. So that's something I'll be doing fairly soon. Probably the next thing I'm going to be doing is that. But yeah, other than that, it should pretty much work. There'll be lots of little things that need fixing with it, probably, but for now, unless there are any major problems, I'm going to move on because I need to get 10x feature complete. So yeah, the next thing, switching configs, hover. Yeah. Oh, another thing, I changed the .10x workspace extension just to .10x because nothing else uses .10x that I know of. The old one will still work; it should do. But if you create a new 10x workspace, it'll be .10x from now on. So that only applies to 10x workspaces, not Solution or Visual Studio workspaces. So yeah, just watch out for that. Yeah, so the next thing I'm going to be working on is memory. As you know, 10x does use up a lot of memory so far. So, I mean, for my main test project, which is Unreal, the shooter game sample, it's currently using up about 14, sorry, after the preprocessor it was 14 gig, which is an absolutely insane amount of memory. I haven't been worrying about memory at all so far, really, because my main concern with 10x is to get it working, which is pretty difficult with the parser, and B, to make it fast. And in my experience, it's always easier to make stuff fast if you don't care about memory, and then later on you can squash memory down. There's always stuff you can do to reduce memory. I've spent my career doing that pretty much. So it hasn't worried me, but now I'm getting close to feature complete, and it's something that does need to be done. And it is something that makes people do a double take when they first start up 10x. How much memory is it using? and I obviously don't want that first initial impression to be a bad one. So yeah, why so much? Why is it using so much memory? I mean, a text editor on its own shouldn't use more than a few hundred meg at most, because just showing a bit of text and loading up a few files is not anything at all. So a text editor on its own should be absolutely minimal memory. So obviously it's the parser that takes all the memory. And I thought I'd take you through why that is and what I plan to do about it. Hopefully it will all go to plan. So why so much memory? If you can imagine, as you probably know, PDB files, symbol files that are generated can get pretty big on a large project. They can easily be gigs in size. If you take PDB files of all the main XE and all the libraries and everything, you imagine loading all of those into memory at once and keeping them in memory. That's essentially what 10x is doing. So there's an awful lot of symbol data in there in the parser. So yeah, let's take you through why it's actually so big. So some of you who've been watching these streams probably have an idea of how the parser works now. I thought I'd take you through where the majority of the memory comes from in the parser. And that's the tokens. So as I said before, when it parses it, obviously tokenizes it, and every single word or symbol is a token. So even like the equals or the plus or the brackets, they're all separate tokens, and a new line token at the end. And a token is currently 56 bytes, which stores this data, just sort of index length, etc., and stuff for the parser when it in the syntax highlighting. I can't really squash it down any more than that, unfortunately. So that's the kind of best I can do there. So what happens is, can you see that? Let's get a pen so that you can see my cursor. So yeah, the text editor obviously stores the text, the char data. And as you're editing that, every time you change a line or a set of lines, it sends that to the parser and the CPP file object that's associated with this file. And this file stores a copy of the text. So you've got the text you're editing here, and then a copy of your text here, which is what the parser initially works on. It does a very simple parse of just sort of to get the keyword highlighting and stuff like that. And then it sends the data to the parse thread, CPP parse thread class. So if you change a line, the line gets sent to CPP file sends the line to CPP parse thread, and the parse thread also stores a copy of the text file, because obviously this can get out of sync because this is parsing asynchronously on another thread. While it's parsing something, you could be editing something else down here and changing CPP file. And when it's finished a parse, obviously it sends the data back to CPP file, which is then what the syntax highlighting uses to show it in the editor. So the reason I need two copies is because these two are working on the same thread. So I can query anything in CPP file from the text editor, the main thread, get the syntax highlighting, and also it deals with stuff like the indentations and things like that. So it's stuff that you need instantly and you can't wait for, is everything in CPP file. And then obviously the parse thread is just working asynchronously, trying to work as fast as possible and keep up. So these yellow lines here represent the tokens. I'll show you down here. So for every line, as well as storing the actual text of the line, it stores the tokens. And again, it stores the tokens here. And the tokens are what gets passed this way and then back when they're finished. So as you can see, we've got 2 copies of the text and 2 copies of all of the token data. So as you can imagine, this token data is pretty big, 56 bytes for every single word or symbol, and it's stored twice. And there's really no way around that. To keep everything running smoothly and the parse thread running asynchronously on the thread, I really need those 2 copies. So as you can see, that's one of the reasons why it takes up so much memory. So let's just had a question. You seem to be putting a lot of effort into C++ parsing, which is great, but how about other languages as P support? I mean, yeah, I'll definitely do other languages in the future. The CPP parsing is just the biggest one. It's the hardest language to parse, I'd say, and that's the one I'm doing first. But yeah, in the future, I'll definitely be looking at other languages. So let's see, what have I got? Yeah, I was just going to go through some quick numbers. So the project I'm testing with has 32,000 files and 8.5 million lines, which is 265 average lines per file. I was just working these out to make sure the numbers were actually sane and correct with what I was using. That's 265 is quite short actually for an average file length in lines. I mean, I've seen some crazy stuff. I saw one file that was 500,000 lines long. It was some SQL file in some external library. It had all of SQL just bunched into one file, and it was 500,000 lines long. So editors have to cope with anything that are thrown at them. Anyway, on average, it's a reasonable amount. And if you look at the text, or the wchar data, it comes to like half a gig, 560 meg, which again is about 34 chars per line. And again, that seems reasonable. So to store all of the just text data alone takes half a gig. And as I said, I'm storing it at least twice in the parser. So the text editor is only storing it for files that are open, so that doesn't really count. But all of the parser data is stored in its entirety twice. So that's still already over a gig just for all the text. And also it stores it in the Workspace search. The reason that's so fast is because it stores all of the source files in memory. So it can just scan through them very quickly. So that's 3 copies of the text, which is about 1.5 meg in total. Gig in total. And the tokens for this project, like I said, 8 million lines, is 120 million tokens in the entire code base, which is a lot. Just over 6 gig of tokens, 13.8 tokens per line. Actually, that should be half, because I'm storing the tokens twice. So yes, that'd be something like 6 point something tokens per line, which again is reasonable, because lots of lines don't have any tokens at all, and comments don't count. So yeah, you can see it does all add up. So just reading a question. If you're storing tokens by line, can you delta compress tokens on a line basis or go further? Token is likely a good predictor for next one. Compress, decompress. Yeah, it's something I've definitely considered. I'll go through some of the things I thought about and what I've decided to do in a minute. But yeah, it's data that will compress very well. I mean, if you just take the parser cache file, which is about 3.5 gig, I think, in this case, and compress it down, it compresses down to about 10%. If you compress things, you always get a perf hit. Yeah, and I did decide not to go down the compression route in the end, but I don't think it would be that much of a hit, because mostly we're talking about, well, I'll come on to that. I'll come on to how I'm thinking it's going to work, but compression is definitely an option. The other one is to cache it out to disk, which is probably what I'll do. So yeah, here are some numbers from the test project. These are all gig. So like I said, CPP parse thread, this one here, 4.72 gig. So that's, like I said, it's the text and the tokens mainly, and some hierarchical data on what it's actually parsing. And then the CPP file is just the text and the token data for syntax highlighting. What I've called database is the central set of parser data, like the tree of all the classes and structs and namespaces and everything, and loads of caches for anything you could possibly ask of it. And that only comes to like less than a gig, which is quite surprising, because I mean, I've always assumed that would be the really expensive one, but it's not compared to the token data. So that's quite nice, because it means that's the data you're using all the time pretty much on all the files, and that's what you need there always. So the fact it's only a gig is really nice. Fast find is the workspace search. Like I said, it's storing all text files in memory, and as I said, text files are sort of half a gig, and it's coming out at 0.75. I'm not quite sure why it's over. I think it stores a few more files than the parser, because the parser is only doing CPP and H files, etc. So I think it's storing a few more files in there. But there might be something I can squash down. And the other thing I was thinking with fast find is that most files are ASCII, so I could just store it as single byte chars for most files, and that would cut it in half. So that would be a really nice optimization. I couldn't compress that because you need it very quickly. When you search for something in a workspace search, all the threads are tearing through the memory, and it needs to be there and hot in the cache. So yeah, compression won't work on that one. Def cache is something that's in a database, and again, 0.71, it's not too bad. And MISC is like loads of caches of stuff and quick lookups. Tree is actually the workspace tree with all the nodes. I'm sure I can squash that down. That shouldn't be like 300 meg. That's too much. So in this case, it was 11. I think I was looking at the non-preprocessor build in this case. So those are the numbers we were working with. Did a bit more of a breakdown here. Yeah, I think I've just gone through all this. So the numbers are slightly different on this profile I was doing last night, because it's on a different build. But yeah, as you can see, tokens are by far the highest, 2.69 in the parse thread and in the cache. File references cache is pretty big. So yeah, those are the numbers. I'll bring up, let's move the microphone. So one of the things I've been using is my Mempro memory profiler. And this Mempro its superpower is that it will cope with anything you throw at it, no matter how big or how long the profile is. You can throw a 30 gig profile dump file and it will just handle it, which is super helpful. Just wait for that to load. symbols. That's a shame. It's weird, they're in the same directory, so it should work. There we go. That's good. So as you can see, this is measuring exactly what's in the build now. This is the preprocessor build now we're looking at. And it does take up a little bit more memory. I actually did an optimization last night, which knocked off about 6% of the memory. So it's a bit better than it was, but it's still about, on Unreal, I think it comes to 18% higher now memory than before the preprocessor build. So that's another reason I really need to look at memory. And so as you can see, the parse thread is 6 gig here, and that's increased because of the preprocessor. And the way I break this down is the grouping editor, and all it is you just put a wildcard in there and a name, a group name. So any call stack, so these are all call stacks, any call stack that matches, that has, say, CPP parse thread read cache in it, will go into this CPP parse thread group. It's a very simple and easy way to quickly break down the entire call tree into different areas. It's a really good way of sanity checking stuff. So yeah, anyway, there's probably not that much more I need to say about that. See my notes. Some options, yeah. So you can see the main reason why I haven't been worrying about the memory too much is because I'm always under the assumption I don't actually have to store all of this in memory all the time, because usually you're only working on a few text files at a time, maybe up to 50 or something, or 100 or something like that, not the whole 32,000 files. No programmer, no matter how good they are, is ever going to be looking at like 8 million lines of code every single day, all the time. You're only looking at a tiny subset. So I don't actually need to keep all of these in memory. That's my theory. I don't know how it's going to work out in practice, but we'll have to see. So I've considered a few things. I could either do like someone said and compress this into in memory, keep it in memory but compressed. And the only time it needs either the text, the tokens or the text, is when you're actually changing data. Everything else you can get from the central database, or I can just keep the text highlighting, keep that live, but everything else can go. So all of this can go, probably everything that's in parse thread and CPP file, I could just get rid of in some way and then only load it up as and when it's needed. And that'd be a huge saving. So in this case, it comes to sort of 7.5, 8 gig. It's out of 11 gig. So that's most of the memory. That's a lot. I'd run some numbers here, and it's like I can get rid of at least, I think, 62% of the memory. Maybe more. Actually, it will be more now because of the preprocessor. So maybe up to 70% of the memory by not keeping all of this data in memory. Now it's a risk. I don't know how it's going to work out, because it might turn out there are things that like when you're finding references or finding symbols, or the hoverbox stuff where it shows you the data. It might be that it needs some data here, and I'll have to sort of load it up. But I still think it's not going to be very much compared to the actual total of everything. And I think it would be pretty quick as well, because most files are fairly small in size. Like the text will only be, a few tens of K in size, and the token data like probably 3 or 4 times that. So we're talking about a few hundred K probably at most for each file. So even if it has to load up a file just to go to definition or something, that shouldn't be too much of a problem. So we'll have to see how it works out in practice, but that's my plan anyway. And there are a number of options of ways to do that. I could, like someone said, compress it, and like I said, that will get it down to 10%. So every file would be compressed just as a blob of data, and then when you open that file or start editing it, it will just decompress it and then work as it does now. So the nice thing is nothing really will change into all the complex code I've got now. I don't have to do anything clever or fancy. I can just compress it and then decompress it as needed. And I think, that would be pretty quick. I mean, decompression is about 3 or 4 times faster than loading off disk typically. So I think it would easily be fast enough to do that. But it's still 10% of the memory, and 10% is quite a lot of like 8 gig or whatever it was, 7 gig. So I mean, the other thing I was thinking was, now I've done the reparsing, I could just reparse it off disk, and I wouldn't say take any memory at all, because I could just completely delete the memory, and then as it's needed I can just reparse it. And because of the way I've done the reparsing now, that it reuses all of the symbol nodes, def nodes, it would just slot into that and not take any extra memory. So yeah, I could just reparse it as needed, which I thought about, but that might be too slow, because if you get a really big file that's tens of thousands of lines long, which can be, it's not unheard of, that you would have probably like a second pause before the syntax highlighting came in. I don't like that. It just makes it feel slow and clunky. So I probably won't go down that route. So what I've decided on is to just cache it out to disk. So as it does the full parse and parses everything, as soon as it's parsed that file, it'll write it to one big cache file. Just like I've got a cache file now, I'll have a separate cache file, which is all the parsed data. And as soon as it parses it, it'll write it out to the file, and then just page it in as needed off the file. So like I said, it's only going to be like a few tens of K, maybe 100 or 200 K or something of data per file. It's not actually that much. And if I'm reading it out of one big file, it shouldn't be too much of a problem. And I may even compress that file in the end of the day, because the files are pretty big. Like I said, I think it was 3.5 gig last I looked. Wow, 4.5 gig. It's gone up. Yeah, that'll be the preprocessor data. So yeah, it's 4.5 gigs. So I think I really need to compress those, especially if you're going to have one per config now. When I've done that, so I think I will need to compress them. But compressing, you can kind of hide behind reading off disk, so it shouldn't be any cost at all. So yeah, that's my plan. To write it out to disk and then read a bit back in as and when it's needed, and have some kind of caching system. So when it saves the parser cache, it will now just save like the main database, like I said, which is about 1.5 gigs or something, and everything else will be in this. It'll be a read-only file. So once it's done a full parse, that file will just be read-only, because it's too much. It's too tricky to actually. Well, I could make it writable, but we'll see. I'm going to make it read-only, and then any of these files that are loaded into memory, because you're editing them, will be saved out to the main parser cache as they are now. And then everything else that hasn't been touched at all will just be read in from this read-only file cache. And I think that'll work quite nicely, assuming that most files are never touched and never needed. They can all stay in the read-only cache and get read in and then evicted if necessary, maybe on a time or last use basis. So that's the plan. We'll have to see how it works. I'm expecting some gotchas, like there are some things that just need this stuff in memory or they're not going to work. But fingers crossed there won't be too much, and I can just page most of it out, and that'd be really nice. Because when you use 10x, although it uses like 14 gig of memory at the moment for this workspace, you'll probably notice that a lot of the time the OS has actually paged most of it out. And I've seen it only taking like 300, 400 meg or so, which is amazing, and still carry on using 10x absolutely fine. So even though 10x uses a ton of memory or commits a ton of memory, it doesn't actually use most of it. It never even touches most of the memory, which is why the OS can page it out so easily. So that's a promising sign. And in a way, it doesn't matter that 10x commits so much memory because the OS is doing this paging for us. But it does scare people when they see how much it starts off at when you first load it up. So it I definitely need to give it a helping hand, let's say. So yeah, I think that was it. I'm probably going to do that for the next few weeks or months. Let's see how it goes. Hopefully it won't be as big as the preprocessor. And it's one of the last major things I need to do, really. There's still a few features that need to be in, but I'm really going for feature complete now on 10x. And feature complete, at least for the first stage to come out of beta, means the C++ parsing, obviously, get the memory down, get all the main features in. Still a few features I need, such as finding files, etc. And to fix and polish, fix some of the main bugs that's down there and polish. And then that'll be it. And that's why I'm putting a lot of the bugs on the backlog at the moment. I did the other day go through the backlog, the issues in GitHub, and I just blitzed through a load of really trivial, easy bugs that would just make it better to use, the quality of life things. So hopefully you'll find it a bit better. Every now and again I'll do that. I'll just go through and just fix a load of easy stuff that doesn't take long. But mainly I need to focus on feature complete now. I just need to get it done. So hope you understand. And I will get to everything in the database, in the bugs database as soon as I can. So yeah, I think that was everything on my list. Yep, that is the plan. So let's see how much I can get memory down. Because the other thing I was going to say about when I get memory down, it's going to be really nice, because when switching configs, at the moment, even when I do the reading from the cache, it's still going to take, like in this project, I think it's about 30 seconds to load everything up from the cache. And currently I can't do that without throwing away the current parser data, because it's just too much memory. I can't double the memory so I can't keep this live while it's reading in the cache for the other config. I would have to throw this away. You'd see the syntax highlight and disappear, and then 30 seconds later it comes back again with all the preprocessed data from the new config. But when I reduce the memory, it'll be a lot quicker. So it'll probably load in only couple of gig at most, maybe 3 gig, and that'll only take a few seconds. So that would be a lot better. And also, like I said, I can keep the current syntax highlighting. Once memory is right down, I can keep the current syntax highlighting, and then when you switch config, I can just load it in the background and then just swap it when it's ready. So you shouldn't actually notice any break in your workflow or anything. It will just, after a few seconds, it will just pop in, and the if-defs will be looking correct. So yeah, reducing memory will help in so many ways. Even like starting the project up, it won't take like 30 seconds to read the cache. It will just be there within a few seconds. So yeah, that's why it's so important, and I can't put it off anymore. It's got to be looked at, and I'm looking forward to doing it, because I'm really hoping it's going to go smoothly. So yeah, that would be pretty exciting. Cool. Okay. So carry on using 10x and carry on giving me feedback and putting bugs in the bug database. And I'll see you next time in a couple of weeks. So thanks, everyone. See you soon. Halloween update gives users a scare. I couldn't want to remember it. Yeah, the scare I had recently was the leak, which was leaking 1 gig a second. So yeah, I don't want to do that again. Cool. Okay, see you soon. Bye.